Hey guys, welcome to Code Decode. In this video, we will be looking into the ways of logging in Spring Boot. Why do we need to do logging? What is the default logging behavior given by Spring Boot to you? How to implement it and how to customize it. There are multiple questions that is being asked around this topic. So let's get started and look at the ways of logging in Spring Boot. Please do like, share and subscribe to support us so that this video reaches to more of the people like you. Hey guys, recently we have launched a course covering an end-to-end full-stack application using Angular as front-end and microservices and Spring Boot as the back-end. Also, we have used Cloud to deploy this application, and we have used CICD, that is Jenkins and Argo CD, for continuous integration and continuous deployment. The technologies that we have used is RESTful web services, Spring Boot and microservices for back-end, Angular for front-end. GitHub we have used for version control system. Also, to make the code unit testable, we have used JUnits. We have used Sonar for code quality checks. Also, for containerization, we have used Docker and Kubernetes. And to deploy this whole application, we have used AWS and multiple services from AWS. Also, we have used SQL as well as NoSQL, that is MongoDB and SQL. On AWS, since for the SQL we have RDS, we have used those services, and Jenkins and Argo CD for CI/CD pipeline. Also, this is an architecture of the application that we have created where the front end is Angular and the back end is microservices. We have used ALB load balancers, Ingress for routing and load balancing. And we have used SQL and MongoDB for SQL and NoSQL DB management with Eureka Server and all those microservices counterparts. Now, this is the CI/CD pipeline. This is the CI/CD flowchart for the application that we have created on local. So this is a flow when you create an application in local, push it to GitHub, create a Jenkins pipeline and do the CI/CD using Jenkins and Argo CD. And at the end, deploy the whole code at AWS EKS. Complete description of this course is covered in a very separate video. The link for that video is also given in the description bar below. And also the link to purchase that course from Udemy is also in the description bar below. So please go and check the description for all these links. So firstly, what is logging? Logging in Spring Boot refers to the practice of recording information, events and actions within the Spring Boot application. So whenever something happens, you must know that that event has occurred. For example, if you have an empty list, then looking at the logs, you should get to know that you have got an empty list from the database. To record such event, we use logging. Usually these logs are redirected to multiple places like console or Splunk, where you can see all the logs, or to a particular file where all the logs are recorded. So basically, logging plays a very crucial role in understanding the behavior of the application, diagnosing the issues and monitoring its performance. Whenever anything wrong happens in our application, the first place you should look at is the logger with an error wherever you are logging your logs. So Spring Boot offers flexibility for logging, and you can integrate the logging capabilities with various logging frameworks. You have a standardized way to configure and manage your logs in Spring Boot. So the next question will be, how is logging actually done in Spring Boot? So Spring Boot offers several logging frameworks with which it can integrate seamlessly. For example, Log4j, Log4j2, JUL, Tiny Logs, logback, and many more. So you can choose any of those to have an integration for your logging capabilities. A logging framework handles various tasks such as defining where the log files are stored and customizing the log message. So this is where you handle your logs, that is log files. Either you have these particular logs in the files called log files, or in the console itself, or redirected to some external application where the streams of logs are seen, for example Splunk. And also you can customize your logging message and format. We will be seeing how to do that in the upcoming videos in the live demo. But the one which comes seamlessly integrated with Spring Boot by default is SLF4j. So in most of the projects, you might have seen that most of the time logging is done using SLF4j in our Spring Boot application. Because with this, it automatically comes integrated in the Spring Boot. You do not have to explicitly configure it. You have everything already by default configured in Spring Boot for SLF4j. What is SLF4J? SLF4J stands for Simple Logging Facet for Java. It serves as a unified interface for these logging frameworks. With just one dependency, user can seamlessly utilize any of these logging frameworks. And these are the logging frameworks you can have. With SLF4J, you don't even need a dependency to be added. Now, what are different levels of logging? This is a very important part. You can have the levels in logging. What does that mean? It means that logging framework provides you different levels to categorize your log messages based on the severity and importance. Now, when you have an empty list from the database, it depends upon your use case. Either you just want to log it up that the list is empty and leave it and go ahead with your code logic. Or you have to throw an exception and stop your code then and there, that list is empty, I cannot proceed anymore. So these are the two different use cases. These are two different severity and two different importance of scenarios. If it is not that important, it is not that severe, just do the log.info. If it is that much severe and that much important that if you have the empty list, you cannot move ahead, then put it as severity is very high, importance is very high, and make it as error. Thus, the common logging levels are categorized based on severity and importance. Now, common logging levels are trace, debug, info, warning, and error. Trace is the most detailed level or the highest level. It is used for messages that provide deep insight into the flow of program, such as method calls, variable values. This level is mainly helpful during debugging and diagnosing the complex issues. Remember, tracing is rarely used. It is used only when you are debugging some issue or trying to find some complex diagnosis into the application. You usually do not go at such a high level of tracing. Second is debug. The messages at this level contains information that is useful for debugging purposes. It provides information as what is insight into what is actually happening into the application, but without overwhelming it with excessive details. In next few minutes, I will show you that if I make it as trace, your complete logs are filled. And it's very difficult to understand what the real cause of issue is. So if you just want to debug some issue, do not make it as trace. You should make it to debug so that at least you will be able to debug some issues. Trace is used when there is something very complex and you need a very deep insight. So this is the highest level. Then comes debug. Then comes info, which is the default one. So informational messages that signify the application's activity, actually written with info. These messages give high-level overview of application state and major events, which is useful for keeping the track of normal functionality. For example, my method is getting started for controller. Then I'm going to just put an info that the controller's method is getting started, and when it is getting ended, I'll just put the logger.info, the method is ended. A simple, very high-level overview of what the major events are happening around. Now comes warning. That is a potential issue indication that can cause problem in the future or highlight the situation that might needs your attention. This is not critical error which will for sure lead to your termination of some application or something, but it is just a warning that you might need to investigate to prevent possible errors in future. The last one is error. This message represents the actual error that has occurred in the application. These includes exceptions, failed operations, or issues that requires attention for proper functionality. So it is on you, whenever you implement logger in your application, to decide that which condition is important enough to be marked as error and not so important enough to be marked as information. Also, one more important thing. These log levels that we have covered in previous slides are hierarchical. What does that mean? It means that the higher level includes all the lower levels. Here it is a descending order. This is the highest level, trace. And these comes the lower level, debug, info, warning, and error. That means if it is a higher level, then it will involve all the lower level also. Now, since the default one is info, that means whenever you are trying to log anything in your application with information, warnings and errors are bound to be logged automatically, either on your console or on your file or on your Splunk based on your handler. So these are hierarchical. That means logging 1 will log all the lower also. Now, if you make it at the highest level, so you make it as log at trace level, then not just trace logs will come, but also debug, information, warning and error. All these logs will also come, which will bombard your handler, be it console, be it file, with loads of logs, which will be a trouble. So remember, if you are setting the log level to trace, you will capture all the log messages, including trace, debug, information, warning and error. This is useful for diagnostic of complex issues, but it is generally not recommended for production due to potential volume of log generated. In few minutes, I'll show you. If I make it as trace, you can see the simple 10 or 15 logs which were coming on application start will become a loads of logs in which searching your issue will be difficult. Thus, logging is always hierarchical. Remember this, if you just log as trace, do not expect only trace logs will come. Every log will come. So choose your logging level very wisely. And how would you choose it? Choose it or customize it using the application.properties. Now, what are the elements of logging? This is very important. For implementing any logging in your Spring Boot application, you have always 3 main elements. First, capture the message. Second, format or customize it. Third, choose a handler. That means whenever you log something, where do you want to see that log coming? Where you usually see it? You see it in console, but you can also see it in file, sent through an email, redirect it to Splunk. So dispatches the message by printing them either on console, storing them in a file, sending it to email or sending it to Splunk. So these are the 3 very important steps whenever it comes to logging. First, capture it. Second, format it according to your needs. This is not important. By default, the message is already formatted for you. If you want to customize it, that is your call. Third, since you have captured it and formatted it according to your need, you need to show it somewhere, because whenever some exception occurs, be it in production, be it in development, you need to see those messages. So where that messages have to be stored, those loggers have to be stored in some handler, should be handled by some handler. That will be either your console or file or Splunk or email. So let's see each of them in detail and let's implement it. So first, how to generate a log. To generate a logger, use logger from SLF Forge. Now here, this is my Spring CRUD. This Spring CRUD application I have already created, where I have a controller layer, where I have CRUD operation of save, find all, find by ID and delete. Then I have an entity with ID and name. Then I have a repository. I have a service layer and the application.properties. The application.properties is going to make me connect with the database. So this is my SQL 1 code, 2 decode. This is my database data with 2 records, code and decode. And that's it. Now in the controller layer, I want to put a logger, and also in service layer, I want to put a logger. How would I do that? So logger equals to logger factory.getLogger. That's what we have seen here, right? Logger equals to logger factory.getLogger in the controller.class. Now my controller name is this. So from where do you think this logger is coming? This logger is coming from SLF Forge. And how does I implement SLF Forge directly without adding anything in POM? So you can go into the POM and see that I have Spring Boot Startup Parent. I have Data JPA and SQL Connector for database. I have web application to create controllers and all. And just a plugin. That's it. Nothing fancy. I do not have any dependency explicitly created for SLF Forge. Still, I'm able to use the loggers and logger factories from SLF Forge because it is given by default by Spring Boot to you. And how do you use it? Do nothing, just use logger equals to log factory.get logger. And for which class I want this logger to be created? For employee controller, I want this class to be created. And how do I use it? To use it, just use this instance logger that you have created with trace, info, and error. This is error. This error will be logged only when some exception occurs, when we will uncomment this. Then only we'll be able to see the error here. Currently, you will be able to see only log.info. You won't be even able to see log.trace. Why? Because by default, the info is the default level of logging. And if default level is logging of is info, then before info, none of the log levels will be printed, because I told you it is hierarchical. So this is first trace, then debug, then info, then warning, then error. So if it is by default info, only warning, error and info will come. Trace and debug will not come. So I'll show you that with the trace log level, this log will not come in console at all. So this is how you implement your logger with SLF4J in a Spring Boot application. Very simple, one single liner and your implementation is done. So the logger has methods that prints the log at the various log levels. For example, logger info of info message. So whatever you put the information here will be printed on console or on file based on your customization. By default, it is on console and not on any of the file. If you can see here, there is no file here explicitly given. So by default, the log level is set to info. But how do you customize it? You can customize it in the application.properties or application.yaml file by putting the trace level at root level or at package level. I'm going to show you how. First, I'll show you how it is working by default. So let's debug this. If you can see, it is by default info. That is why on your console, only info is coming. Then sometimes even warning is coming, because if your info is enabled, by default info, warning and error will come, because it is hierarchical in nature. So if you can see, there are few lines, just these few lines, just 10-15 lines of logs are there when my application got started. Now if I make it to trace, here not just info and warning will come, trace, debug, info, warning, error, everything will come. But before that, let's see whether trace is coming or not here. So let's try to get all employees. So it will be localhost 8080 /code/all. So let's try hitting it. Localhost 8080 /code/all. And I have two records. One code, two decode. So one code, two decode. I have proper data with me. Now I had two logs, trace and info. And since we have not customized anything in application.properties, it's by default info, the trace will not come at all. So you can see here, starting all with the trace log level will not come here in console at all. So yes, in the console, you can see that from the controller layer it starts getting all employee method with the info log level. So only line number 40 is printed and not the line number 39. Why no trace log level is getting printed here? Because the default log level is info and not the trace. If it would have been trace, then info, error, everything would come. But since it is info, the hierarchy above this will not come. So this is what is printed. After this, you go into the service method. In the service method, you have this get all employee in the service layer started, and then get all methods in the service layer ended. And that's where your log ended. And that's where your log ended with the service layer itself. You didn't see error because no error came. We haven't thrown any exception from the method since everything is commented out. Hence, only info is coming in the logs. Also, error will come if I uncomment this. So let me quickly uncomment this and show that when it is just info, then error will also come. Let's debug again quickly. And again you can see only info is coming. Warning is coming. Let me hit this. Since we have not customized it to trace, still by default info, trace is not coming, only info is coming. Then after the info getting printed for controller, at line number 40, the service layer is called. GetAll method started. But since we are making it empty, and since it is empty, we are throwing an exception. We are going to catch it an exception and we are going to print the error. Error saying exception occurred in the service class. So exception occurred in the service class, and the type of this log is error. So that's what I said. If you have by default info, not just info will come, warning will also come, and error will also come. All the three in the hierarchy down will come, but trace and debug will not come. Now how do you customize it is the question now. Now I want both trace and debug also. Now I have to set it to 2 levels up. That is, if I set it to trace, then not just trace will come, debug, info, error, warning, everything will come. So this is how you set it at root level. And since you set it to trace at the root level, now when I debug again, not just info, warning and error will come, but also debug and trace will come. But you will be able to see that these 15-16 logs which were coming for starting an application will become a loads of traces and debugs logs. And your log will become very heavy. And hence it is not recommended for production. So if you can see, in the console you have debug and trace also. Since you have modified the logging level to trace, you not just have trace debug, you also have these many extra logs coming with info also. And now it says it started. Let's try hitting our controller, and now by hitting the controller you will have both the trace log level and info log level. Let's try hitting it. Now you can see here it's very difficult to search our log. So here I can see in the service level exception occurred. So this error log is coming, trace log is coming, debug log is coming. Now let's backtrack for our info and trace logs. You can see here in our controller layer. Now you have 2 log levels, the trace log level and info log level. In our controller, initially trace log level was not at all getting printed, but now not just trace log level is printed, info log level is also printed. After that, the service layer is called, and getAll employees method in the service layer is also dragged with info. Thus, this is how you can customize the logging level at root level. But you can see the amount of logs generated in my console is so much that if actually some exception occurs in production, you will not be able to find out where and how that occurred. So putting it at trace level is a very bad idea. If you put it at debug, it will be much more better. So let's try doing that. But then since debug comes after the trace, you will not be able to see this trace. Here you can see the error and all the debug logs are coming. And here is your information log. But there is no trace log because you have set it one level below trace, that is to debug. Thus the trace logs are not coming at all. Now this debug log will help you debug any issue. So it actually helps you have the dispatcher servlet print which REST API is called, with what parameter it is called, to which employee entity it is mapped to. Multiple debugging things will be printed here which will be helpful for you to debug an issue. So that's how we customize the root level. But now I don't want to customize it even this much at the root level. I don't want to see all these. I just want to see the tracing of my controller, because I know that I want the tracing logs of only the controller or my base package, that is com codedecode demo. So what I'll do is I'll copy my package name, and rather than at root level, I can make it as trace level also, but only at my package level. Thus, I will be prevented by having these many logs, these many heights of logs in my console, and I will have only trace and debug and all the logs at my package level. So see, you only have info and warning for the root level. Again, this is very short and sweet console for starting an application. This is where we have started. So even though you have made it at trace level, you have not made the logging of root at trace level. You have made the logging level of this package at trace level. This is the parent package for all your controller, entity, service, repository and everything. Thus, whenever you hit anything in the controller or any of the service layer, all the trace will come, debug will come, info, warning and error will come. But for the packages which are not codedecode demo, that is not a customized package, will not have the trace level. They will have by default the info level. So let's try hitting it now, and you can see you are able to see some trace and error logs, that is from the controller layer button. So this is how with codedecode demo, you have set it to trace level. Thus you are able to see the trace, info, error, warning, everything. But for all other packages like these, you only have warning, information and error. That's it. No trace, no debug. So this is how you can customize your logs only at some package level also. So we can set the log levels according to your requirement of the application. The format can be set with logging level dot class path equals to level. That's what we have done. Logging level dot root will set it for everything, and logging level dot your class path of the package name, the parent package name, to set it for all the parent and the child packages. So if you put it to info, the root this is by default. But if you put it to debug only for com.codedecode, then only for that package it will be debug, rest all it will be info only. So from this configuration, every class except your codedecode demo class path will have the info. Only this particular package will have debug or the trace. So this is how you can customize your logging level for root or for the customized package based on your needs. Also, let's see how it is formatted by default. So you can see here, this is the format of logging given by SLF4J. Let's decode this. If you can see, this is timestamp. So this is date and time. This is today's date, 29th August at 5:45 p.m. The second is the log level, info, error or trace. Third is the process ID. This number that you see here, that is the process ID. Then you have the thread name. This is the thread in which it is getting executed. Then is the logger name. Now you have put the logger for a particular class. If you can see here, this logger you have created for employee class, and this logger you have created for employee controller class. So these are two different loggers for employee controller and employee service class. So these are the logger class names. And then the last one is the message, the log message. That is, using this logger, you must have logged something. Starting get all method with trace level log. So this is the message. You can customize this format also. We will see how to do it in next slide. First of all, I need to enable some colors. Now if you can see here, all these info, trace, error, everything comes in black. I do not want it black and white. I want it some colored. So how to do that? That can also be done here. You can say that output should be some colored. Now if I try to run it again, you will see the output in some colors. So here you can see the green color is for your log level. The process ID is like this. This is somewhat blue color for your logger name. Now if I try to hit it, your logs will be somewhat colorful. That is, error will be in red, info and trace will be in green, warning will be in yellow. So that's how you can customize your colors on the console based on your type of loggers. If it is red, immediate notice should be given to error. If it is green with trace, info, then it is fine. But if it is yellow, then this is a potential issue that can occur. So that's how you can put some colors to your logs in console. Also, if you want to customize it to have some log file where the logs are created, you can do that also. So currently you can see there is no log file here. Now adding a log file name here will create a logger.log file in the project Spring CRUD here, and all the logs will be appended in this particular logger. So let's try running it again. So these are colorful because of this customization. We are going to have the trace log because we have customized it at the package level and not at the root level. So let's try hitting at the root level. Now if you can see here, logger.log is created as soon as your application is started. Why is it created? Because now all the logs will be handled by this log file and this console. By default, console will have the logs. That is not a question. But this logger file will also have your logs. So if you can see here, all the logs you can see here, the last one you can compare, 3248, with the colors as it is, will be in this file also. So this is how you can change your handler to have your logs not only just on console but also in the log file. Also you can modify the format. So here you can have your YYDD, your seconds and your log level. Now suppose I don't want timestamp, so I can remove it and only have the date where the log level is coming with the level of log, the timestamp and MN. Let's try running this and you will see that after line number 30, you will have logs appended. So let's refresh it again. So you can see again, it is going to start your application. But now your logs is in different format. Before line number 30, it was having this format. Now it is having only date. Why? Because you have customized it with the log file pattern as only date and not timestamp. This is not gonna be the case with the console. If you can see, console still have the timestamp with hours, minutes and seconds. Why? Because you're just changing the log pattern for the file and not changing the log pattern for console. So with this change, these two line of change, you can redirect your logs also to a handler or the logger file. If the log file is not present on the Spring Boot startup, then the file will be created. If it is already present, then these logs will be appended. So logs get stored in this file if it exists, or else new file will be created. And as your logs gets increased, these logs are getting appended in the file with the time. So that was all about logger using SLF4j in Spring Boot. There are multiple more log frameworks like SLF, like Log4j, Log4j2, Lombok, Logback. If you want to know more about all such integrations and how to integrate with Splunk and move these logs to your handler as Splunk, just let me know in the comment section. I'll create more such videos for you. Thank you.